In 1991, a German couple stepped on a human face in the Alps. They called the police, who arrived with a coroner. Everyone assumed it was a missing hiker, until the DNA results came back, and everyone fell silent. The man had been dead for 5,300 years. That's 800 years older than the Egyptian pyramids, more than 2,000 years before Qin Shi Huang, older than any recorded dynasty in human history. But his muscles were still intact, the food in his stomach still there. Scientists could even tell exactly what he ate for his last meal: wild mountain goat with a grain porridge. What really sent chills down everyone's spine, though, wasn't how well preserved he was, it was the arrow in his back. A flint arrowhead fired from the left rear, piercing his shoulder and tearing the artery beneath his collarbone. When he died, he was running for his life, not even able to turn around. Who was chasing him? Why did they want him dead? After 5,300 years, no one can say for sure. And what's even more unsettling, scientists found another person's blood on his right hand, DNA that didn't belong to him. In other words, right before he died, he had just killed someone. What kind of storm had this man stumbled into? Later, this body would get a name. Otzi the Iceman, named after the Ötztal Valley where he was found. But his return to the world was one of the most tragic resurrections in history. Police used pneumatic drills and pickaxes to violently chisel him out of the ice, rough handling with no regard for preservation. When the funeral home staff found his rigid body wouldn't fit in a coffin, they simply snapped his arm to force the lid shut. After spending 5,000 years buried in ice, the first thing that happened to him when he saw daylight again was having his arm broken. It wasn't until archaeologists arrived, took one look at his belongings, that everyone realized, this was no missing tourist. This was a top-tier warrior from prehistory. What was he carrying? A copper axe. 5,000 years ago, copper was far rarer than gold, and owning a fully copper axe was like driving a Rolls-Royce into the mountains, a symbol of elite wealth in that era. A finely crafted flint dagger, its handle smooth and blade razor-sharp. Clearly a well-used weapon. A longbow taller than he was, a quiver holding 14 arrows, but only 2 were finished, the other 12 were half-made. That detail is crucial. He was fleeing while hastily crafting arrows on the spot, ready to fight back at any moment. His clothing was also top-tier: goatskin leggings, a blended fiber coat, boots stitched from deerskin and bearskin, stuffed with soft grass for insulation, basically high-end outdoor gear from 5,000 years ago. No doubt, he was a seasoned, fully equipped prehistoric expert. But his body held a brutal twist. He had the earliest known case of Lyme disease in human history. Arthritis spread from his neck all the way to his knees. Chronic pain tormenting him for years. His lungs were blackened from campfire smoke, making it hard to breathe. His intestines were riddled with parasites, his digestive system was already failing. The white lines on his fingernails were unmistakable, marks left by extreme stress, showing that for months before his death, his body had been on the verge of collapse. In his last meal, besides wild goat and grain, there was a type of fern, a plant used as pain relief medicine back then. A middle-aged man, outwardly tough and well-equipped, yet riddled with injuries and disease inside, climbed through snowy mountains with a body full of fractures. But what truly upended everything we thought we knew, even more than his ailments, came from a 2023 genomic study. Scientists performed a high-coverage whole-genome resequencing of Otzi, and the results stunned everyone. Otzi didn't look like the museum reconstruction. Light skin, dark eyes, full head of hair. The real Otzi had dark skin, dark eyes, and was likely bald. That museum reconstruction of a dashing prehistoric hunter? Wrong. It took humanity 30 years to realize they'd given a wig to a 5,000-year-old bald man. Historical misunderstandings can be more absurd than lies. It reminds us that what we think we see isn't always the truth. Then there are his 61 tattoos, fine lines and cross patterns densely scattered across his lower back, knees, ankles, and wrists. At first, everyone thought they were tribal markings, symbols of status or power. But when researchers layered the tattoo distribution over Otzi's full-body CT scan, they were stunned. Every single tattoo point aligned almost perfectly with the areas of worst joint wear. This wasn't decoration, it was 5,000-year-old acupuncture. In an age before writing was even invented, humans were already battling chronic pain, and had developed a precise system of pain management. In that moment, the 5,000-year gap vanished. The human obsession with fighting suffering has never changed. Now back to the biggest question: how exactly did Otzi die? For 30 years, the consensus was that the arrow severed an artery and he bled out. But in 2025, the University of Copenhagen and the Institute for Mummies in Bolzano, Italy, released a new forensic 3D reconstruction. Using high-precision CT scans and 3D animation, they recreated the arrow's entry angle and wound trajectory, and the conclusion was surprising. The blood clot around the arrow wound was only about 110 milliliters, roughly half a cup of water. The tear was in a small vessel, not a major artery. The arrow didn't kill him directly, but it wounded him, weakened him, and left him unable to descend the mountain. When the alpine blizzard swept down from the pass, nature itself became the true executioner. He wasn't killed by a person, he was trapped on the mountain and froze to death. The shooter let loose an arrow and left, but that arrow kept him forever on that mountain. Who was the shooter? We'll never know. The person who shot that arrow from behind probably thought it was just another chase in the mountains, that the man would die, vanish, and be forgotten. They could never have imagined that 5,300 years later, scientists from around the world would gather around this corpse. Using the most advanced instruments to reconstruct, millimeter by millimeter, every detail of his final 72 hours, every breath, every step. And the killer? Left nothing behind, not even a name. That's probably history's deepest revenge. You think you've won, but the one history remembers is the man who fell in the snow. Today, Ötzi lies quietly in the South Tyrol Museum of Archaeology in Bolzano, Italy, stored in a custom-made refrigeration chamber at -6°C with near 100% humidity. Every 2 months, staff gently spray him with sterile water. Like tending a rare and precious plant. Research has been ongoing since 1991, more than 30 years and still not finished. He is the most thoroughly studied corpse on the planet, bar none. Through his body, he has taught us that Lyme disease existed in prehistory, that Bronze Age humans understood tools and medicine, and that prehistoric migration patterns were far broader than textbooks show. But what he leaves us with most deeply isn't these scientific conclusions. It's a sobering reflection on fate. No matter how strong or experienced someone is, one arrow, one cold snap, one wrong person crossed, and it can all end. Ötzi never made it down that mountain, but his story has crossed 5,300 years to reach today, to appear on your screen. Everyone dies. But some people, even after 5,000 years, remain unforgettable. Do you know what a northeastern Chinese person from 140,000 years ago looked like? In 1933, an ordinary Chinese worker by the Songhua River in Harbin hit something hard with his shovel while digging a bridge pier. He scraped away the dirt and found a massive human skull. He didn't report it, didn't make a sound. He quietly wrapped it up and hid it in an old well near his home. And there it stayed for 85 years. Not until 2018, when the old man lay on his deathbed, knowing his time was near, did he reveal the secret to his family. No one could have guessed that this single dying confession would, by 2025, fill a critical gap in human evolutionary history. And lift the veil on an entire species. Before we talk about this skull, I have to tell you an even stranger story. In 2010, in a cave in Siberia, scientists sifting through a pile of broken animal bones picked up a tiny finger bone, so small it could fit on a fingertip. No one paid it much attention. But after they extracted its DNA, everyone fell silent. That DNA didn't match modern humans or Neanderthals. It belonged to a completely unknown branch of humanity. Excitedly, scientists nicknamed them Denisovans, after the Denisova cave in Siberia where they were found. But here was the problem: this mysterious species had only DNA, no face. For 15 years, anthropology had a cold case. What did Denisovans actually look like? In 2018, that Harbin skull, hidden for 85 years, finally saw the light of day, donated to Hebei Geo University, a scientific institution. Scientists took one look and were stunned. This was one of the largest human skulls ever discovered. Its brain capacity matched that of modern humans, with huge eye sockets, heavy brow ridges, but a surprisingly flat face. Low, broad cheekbones, the whole face looked as if a giant hand had pressed it inward from both sides. Rugged and powerful. More importantly, it is at least 146,000 years old. In 2021, Chinese paleontologist Ji Chang led his team. After extensive research, officially named this skull a new human species, Dragon Man, named after the discovery site in Heilongjiang province, Heilongjiang, the Dragon River, thus the name. The announcement stunned the global anthropological community. But at the same time, British paleoanthropologist Chris Stringer made a telling remark. I have a feeling this skull may not be a new species at all, it's very likely a Denisovan. This statement was widely seen as a bold guess. Until 2025, that guess became fact. On June 18, 2025, Chinese paleogenomicist Fu Xiaomei led her team, in collaboration with Professor Ji Chang's team, published 2 groundbreaking papers on the same day in the top-tier journals Science and Cell. Note, 2 top journals on the same day. That's extremely rare in anthropology. What did they do? Fu Xiaomei's team wanted to extract ancient DNA from this skull. But 140,000 years of time, plus the skull soaking in that dry well for nearly a century, meant the bone was in extremely poor condition. Their first attempt failed, nothing in the bone. So they turned to proteins. Proteins are more stable than DNA and last longer. Since proteins are the product of genetic coding, they can be used to infer part of the genetic information. From the dense bone near the inner ear, the petrous bone, they extracted 95 types of bone protein information. Comparison showed these proteins closely matched known Denisovan bone samples. But Fu Xiaomei wasn't satisfied. She said, proteins are indirect evidence, I need DNA. Then she focused on an inconspicuous spot, the dental calculus on the skull's only remaining tooth. Dental calculus is formed from oral bacteria and food debris. Hard and capable of preserving a wealth of information. But normally, what you find in it is bacterial DNA. Finding the tooth owner's own DNA is extremely unlikely. Like finding a needle in a haystack. But a miracle happened. In that tiny piece of dental calculus, Fu Xiaomei actually found fragments of ancient human DNA. After rigorous screening and comparison, she confirmed that the ancient DNA closely matched the mitochondrial DNA of 7 known Denisovan individuals. The combination of characteristic genetic markers is found only in Denisovans. Dragon Man is a Denisovan, the mystery solved. The significance of this goes far beyond just putting a face to the name, you know? Why can people living on the Tibetan Plateau today function normally at altitudes above 4,000 meters, while others get altitude sickness as soon as they go up? Scientists discovered that Tibetans carry a variant of the EPAS1 gene that allows them to use thin oxygen more efficiently, and that gene came from Denisovans. That is to say, in ancient times our Homo sapiens ancestors encountered, interbred with, and had offspring with Denisovans. The Denisovan genes have been passed down generation after generation, ultimately helping Tibetans conquer the roof of the world. Not just Tibetans, modern East Asians and Oceanian indigenous peoples also carry 1% to 6% Denisovan DNA. If you are from northeast China, you likely share a hidden bloodline with that dragon man from 146,000 years ago, who lived along the Songhua River with a square face. A certain secret blood connection. This is not a metaphor, it's a conclusion from genomics. Of course, this discovery also sparked debate in the academic community. Since Dragon Man has been confirmed as a Denisovan, what should we call it? Use Dragon Man or rename the Denisovans? Some scholars say that the Dragon Man skull is the most complete Denisovan fossil found so far, and should be the holotype, using Dragon Man as the formal name for the entire lineage. But no matter what it's called, one thing is certain, the Denisovans finally have a face. In 1933, an ordinary man hit a skull in a dry well. He probably never imagined that 92 years later, the world's smartest scientists would be arguing over the name of that bone. 15 years ago, the Denisovan was just a piece of DNA, a data point, a symbol. 15 years later, it has a face, thick brows, a broad nose, a square face, deep-set eyes, a calm gaze. Just like an older brother you might run into on a street in northeast China. Human history has never been a straight line, it is an ocean formed by countless converging rivers. We thought we were unique, but it turns out that hundreds of thousands of years ago, our close relatives, the Denisovans, had already climbed mountains and crossed dense forests for us, quietly planting their genes inside our bodies. That is who we are as humans.